In this video, I will discuss the concept of demilitarized zone and the concept of virtual private network. The DMZ is a solution to isolate the local network from the servers that the organization exposes to the internet. Indeed, these servers can be compromised since they are exposed to the internet, and their compromise must not endanger the rest of the local network. A VPN creates a logical private network across the internet. A VPN enables computers to communicate across the internet as if they were directly connected to the same private network. So let's start with the demilitarized zone. DMZ is a subnetwork of the private network that contains services that are to be exposed to incoming connection requests from the internet. An external node can only access what is exposed in the DMZ, while the rest of the private network is firewalled and protected by the NAT mechanism. Since an exposed server can be compromised, connection requests from the DMZ to the rest of the private network must be prohibited. I will show the permitted and prohibited information flows with an animation. The private network is on the left and the internet on the right. The web server exposed to the internet is in the DMZ and is subject to a static entry in the NAT table. That is, it has a permanent public endpoint. The private endpoint is this one, and the permanent public endpoint is this one. I consider here an internet client. The firewall will accept any incoming connection to the public endpoint of the server, and the NAT mechanism makes the internet client to communicate with the exposed server. Incoming connections to local computers of the private network are impossible due to the NAT mechanism. Consider a computer from the private network that has initiated an outgoing connection to the internet. This computer has a dynamic public endpoint, which is this one. The firewall will block incoming connections to any public endpoint which is not a static public endpoint. Although we have seen in another video that two collaborating peers can get around this rule by using the UDP hole punching trick. Local computers may connect to the web server located in the DMZ. I don't want to enter into detail, but local computers will use the private endpoint to connect to the web server, unless there is a special feature implemented in the NAT router which is called NAT hairpinning. This feature would allow the local computers to use the public endpoint to connect to the web server. But this is not very important. The important thing is that local computers may connect to the web server. However, the opposite, that is, the web server connecting to a computer in the local network, must be prohibited by the firewall. This prevents local computers from being compromised if the web server is compromised. By the way, in this figure, I represented only one firewall, but in practice there would be two firewalls, one between the internet and the private network, and one internal firewall between the DMZ and the rest of the local network. One more thing about the DMZ, how DMZ and proxy servers interact. If the organization uses a reverse proxy server, then this proxy server must be located in the DMZ and associated with a static public address. In this case, the web server no longer needs a static translation, but it must stay in the DMZ. If the organization uses a forward proxy server, then this proxy server doesn't need a static entry and has nothing to do in the DMZ. It must be in the private internal network. Let's talk now about the virtual private network. Consider a private network on the right and a distant computer on the left. Between the private network and the distant computer, there is Internet. A virtual private network, VPN, represented by this yellow cylinder, extends a private network across the Internet and enables users to send and receive data as if their computers were directly connected to the private network. From a logical point of view, everything is as if the distant computer was directly connected to the private network. There are several VPN protocols operating at different network layers. All of them use the concept of tunneling protocol. A VPN tunneling protocol is a communication protocol allowing private network communications to be sent across the Internet through encapsulation and encryption. So in this animation, I will show how a VPN SSL tunneling protocol works. Such a tunneling protocol encapsulates IP packets within SSL TLS packets. On the left, we have a corporate network, and on the right, an employee of the organization working at home and connecting to the organization's private network via a VPN. The public IP address of the VPN server of the organization is this one, 1.1.1.1. The public IP address of the employee working at home is 2.2.2.2. The employee uses a VPN client with private address 10.0.0.10. Please note that this private address is not the private address of the employee's computer in the home network. I ignore the home network in this animation. This is the private address that the computer has in the private network of the organization, since the purpose of the VPN connection is to logically connect that computer to the private network of the organization. There is an SSL TLS connection between the VPN client and the VPN server. Now, suppose the employee wants to connect to the FTP server whose private address is this one, 10.0.0.1. The employee uses an FTP client over the VPN connection. And this is the FTP packet that should go from the employee's computer to the FTP server. The source IP address of this packet is the private address of the employee's computer. And the destination IP address is the private address of the FTP server. This FTP packet is encapsulated within an SSL TLS packet that will circulate on the Internet. This is the tunneling principle. The source IP address of the TLS packet is the public address of the employee's computer. And the destination address is the IP address of the VPN server. Since the tunnel is an SSL TLS tunnel, the FTP packet is encrypted. Once the TLS packet reaches the VPN server, the FTP packet is decrypted by the VPN server and delivered to the FTP server. The response packet of the FTP server is then encrypted by the VPN server into a TLS packet, which is routed to the employee's computer. The client VPN decrypts the FTP response packet. As I said, tunneling protocols are at the basis of VPN. Any layer can be used to set up a tunnel. The example of the previous slide is based on TLS tunneling, where IP packets are wrapped, encapsulated into TLS packets. This tunneling protocol therefore works at the transport layer. In the tunnel mode of IPsec, the entire IP packet is encrypted and then encapsulated into another IP packet. This tunneling protocol works at the IP layer. In the SSH tunneling mode, IP packets are encapsulated into SSH packet. This tunneling protocol works at the application layer. There are several VPN deployment models depending on the need. I cannot go into detail, and I would say that if the need is to access to DMZ resources that are not exposed to Internet, then the VPN server must be in the DMZ. If the need is to access to all resources of the private network, as in the case of the employee working at home, then the VPN server can be in the network that is not part of the DMZ. Or the VPN server can be in the DMZ, but in that case, special firewall rules should let it communicate with the rest of the network. But in fact, this is very schematic, and there are in fact many deployment models with subtle differences between them. Please note that virtual private networks are a common vector for cyber attacks. If an attacker can get onto a network via a VPN connection, because he stole some credentials or because he exploited a vulnerability in the VPN server, then this attacker becomes an insider and he can start searching for internal vulnerabilities to install malware, for example. In this video, I presented the concept of DMZ and virtual private network. Regarding the VPN, I considered the case of an employee working at home and accessing to the private network of its company. There are, however, other applications of VPN. For example, there are many internet companies that offer VPN services. These VPN services are not for connecting to a private network. They are mainly used to hide the IP address of the customer who connects to a third-party server via the VPN. This use is a bit like a client connecting to a third-party server via a forward proxy server. VPNs can also be used to bypass the firewall rules of an internet provider, since a tunneling protocol can be used to encapsulate a protocol that would be blocked by the firewall of the internet provider.